Hey guys, in today's video I'll be going over vector mechanics for engineers. I'll be covering forces and equilibrium in space. In this video I'll be covering 5 problems, which I'll have timestamped in the description. If you do like these videos, make sure to like and subscribe, so I know to keep on making similar content. Thank you so much for listening, and let's get on to the first problem. For the first problem, we have a frame ABC is supported in part by cable DBE that passes through a frictionless ring at B. Knowing that the tension in the cable is 385 newtons, determine the components of the force exerted by the cable on the support at D. In order to solve for the components of the force exerted by the cable at support D, first we need to know the length of the cable, as well as the direction of the force, which is if you recall the components of the force, which is represented as a vector, F is equal to the magnitude of the force, which is a scalar, times lambda. And lambda is the unit vector along the line of the force. Another way of writing this equation is the force times the magnitude of the force times the vector dB over the magnitude dB. So the vector dB is equal to, if we have positive c in this direction, positive x in this direction, positive y in this direction, the vector dB is equal to 480 I minus 510 J plus 320 K. The magnitude dB is equal to the square root of the x component of the vector squared, the y component of the vector squared, and finally the z component of the vector squared. And this gives you 770 millimeters. So finally, substituting in the values in this equation, we end up with, so the force is equal to the magnitude of the force which is given to us, times the vector dB which we solve for. All over the magnitude of the cable dB, which is 770 millimeters. And this gives you So there you have it, guys. The components of the force is equal to 200 newtons I minus 255 newtons J plus 160 newtons K. For the second problem, we have the boom OA carries a load P and is supported by 2 cables as shown. Knowing that the tension in cable AB is 183 pounds and that the resultant of the load P and of the forces exerted at A by the 2 cables must be directed along OA, determine the tension in cable AC, and also determine the magnitude of the load P. So in this problem, we need to determine the tension in cable AC, as well as determine the load P. So first of all, I want to set up the free body diagram at the end of the boom at point A. So I'm just going to redraw the coordinate system. Here we have point A. Here we have the end of the cable at C. And here we have the end of the cable at B. So here's tension AC. Here's tension AB. We also have a force P going vertically down. Next, we can find the vectors and the magnitudes for the cables. Vector AC is equal to minus 48I plus 25J plus 36K. And the magnitude AC is equal to and this gives us 65 inches. We can do the same for the vector AB, and this will give us minus 48I plus 29J minus 24K. And the magnitude gives us 61 inches. If you recall, the tension AC is equal to its magnitude times the unit vector, and this can be broken down into the magnitude AC, and this gives us tension AC times minus 48I plus 25J plus 36K over the magnitude, which is 65. And tension AB, the vector is equal to its magnitude times the unit vector, which is the same as tension AB, times the vector AB over its magnitude. And this gives you the magnitude for the tension as given to us in the problem, which is 183, times the vector AB, over 61. So now it's given to us in the problem that all the forces exerted at A must be directed along OA. So what this means is the sum of the forces in the Y direction and the sum of the forces in the Z direction has to equal to 0, because the resultant forces is directed along the boom, which is in the X direction. This must mean that the sum of the forces in the Z direction has to equal to 0. So now taking the Z components from tension AC and tension AB, this will give us so this is the Z component of the tension AC, and the Z component for tension AB is equal to therefore the Z components of tension AB and tension AC has to equal to 0. So tension AC over 65 times 36 minus 183 over 61 times minus 24 has to equal to 0. When you solve for tension AC, you get 130 newtons. Solving for the load P, you get the sum of the forces in the y direction has to equal to 0. Therefore, we need to take the components of tension AB and tension AC in the y direction. And this gives you tension AC over 65 times 25 plus 183 over 61 times 25, and this is for tension AB, minus P is equal to 0. And plugging in the value for tension AC, which is 130 newtons, we can solve for P, and this will give you 137 newtons. So for the second problem, we solved for the tension AC, which gave us 130 newtons, and also the load P, which gave us 137 newtons. For problem 3, we have 3 cables are used to tether a balloon as shown. Determine the vertical force P exerted by the balloon at A, knowing that the tension in cable AD is 481 newtons. First, I'm going to set up the free body diagram at point A, along with the coordinate system. So I set up the tensions for the 3 cables, as well as have a vertical P force going upwards. Next, we need to find the vectors AB, AC, and AD, along with its magnitude. So this will give us... So from A to B we have minus 4.2i, minus 5.6j. From A to C we have plus 2.4i, minus 5.6j, minus 4.2k. Finally, for AD we have minus 5.6j plus 3.3k. Also for the magnitudes, I'm not going to go over the calculations because we did a couple for the last 2 problems. So the magnitudes for AB would give us 7 meters. The magnitude for AC would give us 7.4 meters. And finally, the magnitude for AD would give us 6.5 meters. We know that tension, AB, is equal to its magnitude times the unit vector, which is equal to the magnitude times the vector AB over the magnitude AB. This is equal to tension AB times the vector AB, which is minus 4.2i plus minus 5.6j over the magnitude AB, which is 7 meters. Simplifying this, you get minus 0.6i minus 0.8j times tension AB. And we can do the same for the other two tensions. It'll give you tension AC is equal to the magnitude of tension AC times the vector AC over the magnitude AC. This will give you tension AC times 2.4i plus minus 5.6j plus minus 4.2k over the magnitude AC, which is 7.4. Simplifying this, we get, and this is equal to 0.324i minus 0.757j minus 0.568k times tension AC. Finally, tension AD is equal to its magnitude times the vector AD over the magnitude AD. And this gives you tension AD times minus 5.6j plus 3.3k over 6.5. And this is equal to minus 0.862j plus 0.508k times tension AD. So now we know that the sum of the forces in the x is equal to 0, sum of the forces in the y is equal to 0, and sum of the forces in the z direction is equal to 0. So what this means is we can equate the components of the tensions in the x, y, and z directions to 0. So it would be sum of the forces in the x minus 0.6 times tension AB plus 0.324 times tension AC, and that's equal to 0. So we took the components in the x direction and equated them to 0. We're going to do the same for the sum of the forces in the y and z. So this would equal to minus 0.8 times tension AB minus 0.757 times tension AC minus 0.862 times tension AD. And don't forget the vertical force P. So that'll be plus P, and that's equal to 0. Lastly, the sum of the forces in the z direction, that would be equal to minus 0.568 times tension AC plus 0.508 times tension AD, and that's equal to 0. In the problem, it's given to us that the tension in cable AD is 481 newtons. So now there's a few ways to solve when you have 3 equations and 3 unknowns. We can use substitution, we can use a matrix, or you can even use a calculator. But in this example, I'm just going to use substitution. And this will give us, so sum of the forces in the z direction is equal to minus 0.568 times tension AC plus minus 0.508 times 481, which is equal to 0. Therefore, tension AC is equal to 430.19 newtons. So now, since we know what tension AC is equal to, we can solve for tension AB in the sum of the forces in the x direction. So the sum of the forces in the x direction is equal to minus 0.6 times tension AB plus 0.324 times tension AC, which is 430.19, which is equal to 0. So tension AB is equal to 232.30. And finally, since we have tension AB, tension AC, and tension AD, we can solve for P. So substituting in the values and the sum of the forces in the y direction, it'll give us minus 0.8 times tension AB, which is 232.30, minus 0.757 times tension AC, which is 430.19, minus 0.862 times 481, plus P is equal to 0. So solving for P, you get 926.12 newtons. So there you go, guys. We solved for tension AC, tension AB, and the vertical force P. Alright guys, I decided to wrap up today's video here because the video was turning out to be longer than I had hoped for, so I'm going to be releasing the next video with the remaining 2 questions. Thank you for tuning in, and I'll see you in the next video.